Hey, my dudes, today's the day. Today, we're going to go over the difference really between ddx and dydx. I mean, in calculus, we learn a lot about different, like new vocabulary like differentiation or differentiating or derivative or differential, all these D words especially. But today, we're going to go over the difference between these two. So let's start. So we really have to understand the difference between something that you are doing versus the action or the done action. So something you've already done. So here's an example. So right now I am recording. So I am recording right now. The finished project or the finished product will be a finished recording. So because I'm recording right now, it will bring a recording. Same thing with doing makeup. When you do makeup, you end up getting a caked face. Haha, just kidding. When you're eating food, hopefully you'll get a full stomach. So first, we have to do something. We're doing something, and then there's going to be a result or a product, something in the very end. And that's actually what the difference between this is. This right here is doing something, and this is the finished product. So let's look on how it actually. Let's look at that actually. So a little more background too. If we look at our regular equation, what we can do something to one side as long as we do it to the other side as well, because that will still keep it equal. So we have that right there. And even if we really want, we could technically do, say, the natural log of the square root of x. That's still going to equal the natural log of 3 in this case. As long as we do something on both sides, that is what matters. Oh, but if you just noticed, I said something that we can do. Oh, hey, look at that. Something we're doing. So let's look at the application with calculus. So right here, we have an equation. So now let's do something to this equation. Or, hey, let's do d dx on both sides. So now we do d dx on the other side. 3x squared plus 7x minus 3. And this, what we just did, this is called differentiating. That's just what we did. And so now, what we have on the right side, we have 6x plus 7, and then plus 0. And that is from, the power rule that we learned. The left side, something kind of cool and something kind of fancy. A lot of mathematicians like myself are very lazy. Efficient. So we kind of get rid of the parentheses because it looks like we're just multiplying. It's just something a lot easier to write. And so, let me clear this. So yeah, that's basically the difference. And this right here would technically be the derivative. So if you remember, when you actually do the thing, it's differentiating. And the other one is the derivative. So now what we can go over is, something that you might have seen a sneak peek of. The d squared y dx squared. This is when you take the second derivative, or, you differentiate it twice. And the reason why it looks like this, because I remember I was always confused, why is the 2 here, and why is the 2 here, why are they squared? And this is actually how. So if you remember from the previous slide, we saw this thing right here. So when we take the derivative with respect to x of y, that's going to be dy dx. Oh, but if we take it again with that whole thing, d dx, should be the second derivative. So in this case, the second derivative would be 6. Again, with the power rule. And so with this right here, if you notice that there are two d's right here, it looks like they're multiplied together, so d squared will look like we have a dx times a dx on the bottom. So that would be the dx squared. Oh, and then again, lazy mathematician sound. Oh, sorry, efficient. We can then put the y out in front. And so this is a lot easier than this whole thing. And that's actually where that comes from. And you do that so on with other, like the third derivative, stuff like that. And that's it. Any questions? Let me know in the comments, or if you see me, you see me. All right, good luck out there. We'll see ya. Bye.